Okay. So in the last class, we talked about uh, convergence of series, right? And some of those tests I provided to you. And most of these tests are given in the book by Thomas Calculus, that section I mentioned to you to look at it. Okay. And then I think towards the end of the lecture, in the last class, we started limit of a function. And I'm right now worrying about the real valued functions, right? So I will again start with the formal definition. I think I gave you some idea about how to look at this problem. And then I'm going to do a couple of examples, especially two kind of examples. How to compute limit of a function using epsilon delta business. Okay, this is something I don't know whether you know about this method in your JEE exam or not. I'm not sure, but that's something very important. And then I will also show you that some limit does not exist using epsilon delta. This epsilon delta business you will remember forever in your life. Okay, this is such an important concept, and these are the basic things. So what happens when you are actually dealing with any engineering problems where you know normal formulas are not going to work, whatever you are remembering in the table and so on. So in that case, you have to approach with the basic, and this basic things will help you to provide you some information about the problem that you are looking at. Okay, that's why these are important. So I'm stressing on these things. Okay. Okay, so I think you remember limit of a sequence we talked about, and this was the definition for limit of a sequence Sn. For every epsilon positive, there exists a positive integer capital N such that distance between Sn and L, that means mod of Sn minus L is less than epsilon for every n greater or equal to capital N, right? So that this also reads sometime for sufficiently large n. For smaller n's, it's okay that if they are far away, but for sufficiently large n, they are very, very close. Okay. So this is that means the term of Sn lies in the neighborhood of capital L for all values of small n greater than capital N. So starting from Sn plus 1, Sn plus 2, and so on. Right. So that was the thing. And now when we move towards limit of a function, so now of course the function has of domain, and I think you had enough practice of finding a domain of a function, right? Okay, in your JEE exam, right? That's very, very common problem. So in that domain, function is defined from domain, which is a subset of R to R. Okay. Now I have to compute the limit of f of x. F of x is a function as x tends towards a. A is a point on the real line. So what I do, I draw a neighborhood of a. A is a point, and a minus delta and a plus delta. So delta on that side and delta on this side, right? There is a neighborhood of a. Now that means basically x lies between a minus delta and a plus delta, right? X lies between a minus delta and a plus delta, right? And that is nothing but that absolute value of x minus a less than delta. This is the easy inequality, right? You can just see that, right? So because that means minus delta less than x minus a less than plus delta. This inequality means, right? And that means a minus delta less than x less than a plus delta. Okay. So one thing you will notice, so basically this captures this neighborhood business, this inequality, but I am interested in deleted neighborhood. Means I put this condition that this is positive. So that means this is known as deleted neighborhood, means because when we are computing limit, the function may not be defined at x equal to a. A very good example is sin x by x. This function is not defined at origin, right? So if you take limit x tends to 0, we can define the limit, but the function may not be defined at okay at that point. So that's why we look at deleted neighborhood. So as long as x approaches towards a either from this side or from this side, right? Image of this lies in the neighborhood of L for some epsilon positive. So this distance is epsilon and this distance is epsilon. right? So this is the neighborhood of L. So basically, you need to understand this idea of neighborhood of a point. This is very, very important, right? So as soon as X approaches towards the point A, either from left-hand side or from the right-hand side, its images are in the neighborhood of point L. If this happens, we say that limit of f of x as x tends towards A is L. Okay, that is the key idea. So this is L. This is L. Okay. Okay. So formally, we can write it down, this definition as limit of f of x as x tends towards A is L if for every epsilon positive, there exists delta positive. Epsilon and delta are positive numbers, okay? Such that whenever 0 is less than mod of x minus A is less than delta, this implies that mod of f of x minus L less than epsilon. This is the formal definition of this. Coming from that picture, you can make sense out of it, right? As soon as x approaches towards A, so this, the first inequality means x approaches towards A either from either side. Its images, I mean, this line is not necessary, you know, writing mistake, but mod of f of x minus L is less than epsilon, right? So that means the image lies in the neighborhood of L. Any question at this point? Because this is very, very important. Any question? Do you understand this definition of epsilon delta? No? What is the doubt? Ask. Because if you don't understand this, you will be having trouble all along the line, right? So please do ask, yes.
What are we assuming delta here to be?
Some positive number. ST positive number, yeah. So basically you will see, I will show you again. So this delta basically depends on epsilon. Epsilon, another positive number. So I think when I do some examples, probably you will be able to see what is happening, right? And the best way to understand this is just try to vary, you know, delta and epsilon. You will see that. I'll actually show you the relationship also, right? So, but the idea is, so basically delta is the size of the neighborhood of A, and epsilon is the size of the neighborhood of point L, right? Because epsilon on this side and epsilon on the other side, right? So the idea is as x approaches towards A, so that means in a loose terms, whenever x is in the neighborhood of A, its images are in the neighborhood of L. If this happens, then limit of f of x as x tends to A to O is L. That's a very simple idea, right? Any question again? Any question? Do you understand this definition? Ask questions, because otherwise there is no point. You will read. Yeah. Because now things will become more and more beautiful. Okay. So I need to observe. This is very beautiful. I love this definition actually. See, think about it, how they are able to formulate it. Really nice thing. And the best way to actually analyze this thing is just use some calculator or some maybe MATLAB or something, some computer software or programming, and see when you vary x towards A, if the limit exists, right? You see image automatically varies in the neighborhood. It's a very beautiful thing, right? You just give different values of x. Okay, yes.
if once again.
Yeah. So what I mean, for every epsilon positive, there exists delta. So limit of f of x is L as x tends towards A. If for every epsilon positive, there exists delta positive such that whenever 0 is less than mod of x minus A is less than delta, mod of f of x minus L is less than epsilon. So basically what happens, so what you should do as an exercise. I'll take some examples, okay? And in that example, what you do, vary x. So you know A is fixed, some real number. Take x in the neighborhood of A. And you see, initially suppose you take that neighborhood is say 0.1, okay? And see what is the values of f of x coming. And you change the value of delta, say 0.001. Then you see what happens, okay, to epsilon. This relationship is very beautiful. So you just try to vary and see. You can do some calculator or program. Yes. So basically what happens, this is the size of the neighborhood. It is in your hand. So it says that for every epsilon positive. So if I take epsilon to be very small, delta, so basically depending upon delta, the epsilon will, size will vary. So there is a relationship between delta and epsilon. Okay. So, yes. So if the limit exists, this will happen. If not, then there is a problem. Okay. Yes, every limit. This is a very beautiful. You need to. There is no need to memorize. You need to observe the beauty. You just observe it for 1 minute and you see the beauty, right? Who is not able to feel the beauty of this result? Are you able to feel the beauty? And the best way is, as I mentioned, being that abstract things you may not be able to grasp it. So what I should say that just vary x. Take epsilon to be say 0.1, okay? Take some function, okay? Say suppose f of x is equal to 1 by x, okay? And okay, if you take 1 by x and take x tends towards 1, x is equal to 1, so a is equal to 1. Now vary x in the neighborhood of 1, okay? Choose different delta and you see the different epsilon. Those kind of relationship you will observe automatically if the limit exists, right? So please do this exercise. I want to see today on the WhatsApp group that variation. Some people have done those calculations. Either you calculate by hand, which may be difficult for you, right? So you can use some calculator or some computer program, or you can use Wolfram Alpha, or you can use MATLAB, right? Or Mathematica, anything you can use, right? Use some computing tool to see this variation. Got it? Just vary. Take a cup of tea, sit down in the garden and just vary these values, right? And you observe the beauty, right? So this is something very, very important. Now let us move further. So I think I can also mention something about left hand limit and right hand limit. Oh, okay. As an example, what I would suggest. You know this limit. Now what you need to do, this is your A. Sorry, this is your A. A is equal to 0 here. This is your capital L. L is equal to 1. This is your function. Now you choose, see the power of delta and epsilon. Choose some small numbers and see what happens. Compute this distance, right? Okay. And you will automatically observe what is happening, okay? So just try different variations. So you can take, say, delta could be 0.0001. And also similarly, you see what epsilon you are getting actually. Okay. So there are two more related things, right hand limit. If x is greater than a and x approaches towards a, then we know that from right hand side, then we say that everything remains same, that for every epsilon positive, there exists delta such that mod of f of x minus, say some number L1 this time, less than epsilon, whenever a is less than x is less than a plus delta. Right? So in that say, we say that limit x tends to a plus f of x is equal to L1. Right hand limit. Right? Now, image of x lies in the neighborhood of L1. So then we say the right hand limit. You know about the right hand limit, right? But the definition in terms of epsilon delta is this: whenever x is in the neighborhood, so on the right hand neighborhood of a, right, between a and a plus delta, when x varies there, its image is in the neighborhood of L1. Got it? Similarly, left hand limit. So I don't have to write it. I mean, that's okay. So I guess let us do one example, and now you will enjoy the beauty. First, I'm going to show you that what is this limit? X tends to 0 sine 1 by x. Huh? 0. Oscillatory behavior, very good. If you know this function sine 1 by x, right? So this limit does not exist. Okay? Actually, with epsilon delta, it is very easy to show that something does not exist. Very easy. Showing that something exists requires some calculations. So that's why I've taken the easiest case first. Show that something does not exist. This is very easy. Okay. So what you need to do, the definition, you know, for every epsilon positive, there exists delta positive such that mod of f of x minus L is less than epsilon whenever 0 is less than mod of x minus A less than delta. Yaad ho gayi na? You will remember it forever. Huh? As I mentioned, even if at your, towards end of your life, you will remember this definition. Such a beautiful, as I mentioned, many of the students, they come and meet me after 15 years, they say, I only remember epsilon delta for the whole BTech. Okay, this is very beautiful concept. Okay, so I have to show that this limit does not exist. And as I mentioned, I think you have seen in the example of sequence that something does not exist, right? We assume it exists, right? Same thing here. Assume that it exists. Okay, suppose this limit is L. When I make this small square open, means proof starts. Suppose there exists a real number L such that limit x tends to 0, sine 1 by x is L. Any issue? Any question? See, I'm not going to do too many examples, but whatever I'll do, that is enough for you to understand everything. You don't have to read anything else after this, right? This much is enough. So suppose there exists a real number L such that limit x tends to 0, sine 1 by x is L. Okay? Now what you have in your hand, you have the definition. You just write down the definition. That means for every epsilon positive, there exists delta positive such that mod of sine 1 by x minus L is less than epsilon. Any issue? So whenever 0 is less than mod of x is less than delta. Right? Definition. I'm not doing anything else, just written the definition, right? Now remember, I have to arrive at a contradiction. So I don't have to show this for every epsilon, right? So I can take some epsilon for which I arrive at a contradiction. This is very important thing to remember. Because I have to arrive at a contradiction. I know that limit does not exist. So what I am going to do, I will choose such kind of epsilon so that I arrive at a contradiction. Okay. So very simple thing, because I can take epsilon. So take epsilon is equal to 1. And how, you may ask, who is going to tell you what epsilon to take? And the answer is beauty of function, right? You just observe the function for 2-3 minutes. You will get an idea what epsilon I should take. And you may say that, how do you develop this? I think each of you have that observing the beauty, right? So you can observe, right? So just observe it and you will get it. So I'm going to choose epsilon. Take epsilon is equal to 1. This is very, very important. I'm able to do this because this is true for every epsilon. If this limit exists, it should be true for every epsilon. So I'm taking, okay, 1 epsilon. Take epsilon is equal to 1. And then I write down the definition, what happens? Then in that case, there exists delta positive such that mod of sine 1 by x minus L is less than 1 whenever 0 is less than mod x less than delta. Any question? Any question at this point? Up to this point, any question? Crystal clear? Epsilon को एक ले लिया, definition को लिख दिया. Now what? I have to arrive at a contradiction. Now we know that I'm going to ask some questions. Now this comes from observation, you know. I look at this function sine 1 by x. Are there some values for which this function is plus 1? There will be some values, right? I can find out those values, right? And similarly, I will be able to find some values of x for which this function is minus 1. We can do this. This comes from the observing the beauty, right? There is no other way, right? Look at the sine function. Okay, this should be a possibility. So I'm going to choose those values of x, okay, and see what happens. Okay, so now we know that since sine 2n pi plus pi by 2 is sine 4n plus 1 by 2 pi, whole thing is 1 for any n. This is the observation, right? If you take these values of x, I mean, so we know that because sine 2n pi plus pi by 2 is this value, which is 1 for any n in n is a natural number, right? This happens. Okay? ये तो मालूम है. So now that means what x should I take? This implies that sine 1 by x is equal to 1 for x is equal to 2 divided by pi 4n plus 1. Right? For this value of x, sine 1 by x is 1. And now this value lies between 0 and delta, for some delta, right? In the neighborhood, because you see, automatically it is coming into this delta, right? So I say that, okay. Hence, why this? Because the limit, you know, limit of this value as n tends towards infinity is what? 0, right? We know this value is 0, right? So that means this implies that equation 1 gives you, I think there is some problem in the pen, but anyway. Mod of 1 minus L is less than 1. This is equation 2. Because of this condition, right? So basically we are saying this, so for some x 0, 0 and delta. Some x between 0 and delta, this inequality will hold because sine 1 by x is 1. Okay. Similarly, I can find certain values of x for which this sine 1 by x is minus 1. Right? Similarly, since sine 2n pi plus 3 pi by 2 is minus 1. There will be x in 0 comma delta such that sine 1 by x is equal to minus 1. So mod of minus 1 minus L less than 1. Right? Observing the beauty of sine 1 by x, we found certain points in the neighborhood of 0, right? In the neighborhood of 0, for which this value is plus 1. And for other values, it is minus 1. Now, these 2 and 3, can they hold together? No, right? They cannot hold together for a fixed number L, right? So there is a contradiction. See how easy it is to arrive at a contradiction, right? 2 and 3 cannot hold together. So contradiction. This implies that our assumption was wrong. So limit x tends to 0. Sine 1 by x. This is very bad pen. Actually, I am not sure what is happening. Does not exist. Okay. So this is very easy. Showing that something does not exist. Take some epsilon. You may ask, who is going to tell you what epsilon should I take? Just observe the function, Here you see why, because we know that sine function, right? Sine plus 1 minus 1 is possible, right? It will be easy to arrive at a contradiction. So we are taking that thing, right? And if I take epsilon is equal to 1, it makes sense, right? All pieces make sense together, right? कोई भी छोटा सा प्रश्न हो तो पूछ लो, क्योंकि यहाँ से अभी जर्नी और ब्यूटीफुल होने वाली है, right? Interesting. So, because I know that this is the first time you are encountering epsilon delta, I think it should be compulsory part of JEE exam, right? So, आधी जनता तो एग्जाम देने ही बंद कर देगी, right? क्यों? So, any question? Clear? Huh? So, proving that something is not possible is easy. Assume it is true. Now, since it is true, it should be true for every epsilon. Epsilon is in our hand, so I'll take some epsilon for which I arrive at a contradiction. Okay? Yes? Previous slide. Okay. Yes. एक मिनट. अच्छा फोटो खींचना. Okay. हाँ बताओ.
In this example, we have not taken any specific value of delta. We are just saying that
because those points, because the limit as n tends to infinity, all those goes towards 0. So they are in the neighborhood of 0 only, right? If you take some values of n, it will show you how close, right? Right. Correct. Okay. So now, yeah. So now is the another most beautiful thing that I'm going to show you, showing that limit. Example is very simple. You will say that okay, इसके लिए क्या करना है? Why we are using epsilon delta? But the real beauty lies in epsilon delta only. Okay, and so I'm going to do that example. Show that the limit is this value. Okay, some value, and so be careful. चाय का कप तो है नहीं, but otherwise you will enjoy this example. Okay, see. Yes. Because we have to take we are arriving at a contradiction, right? So we can choose specific values. Okay. For contradiction, there is no problem. But actually, if you have to show that something exists, is there, the value, then you have to do certain other things. Okay. Okay. So now we are ready with our next example. Okay, we know that limit x tends towards 3, x square plus 2x is how much? There is some problem, or I am not good at writing with these pens. Is what? 15, right? You have to show this by epsilon delta. So the real beauty is going to come now. How will you show this with epsilon delta? Okay. Any idea? How should we approach? I mean, we need to think about how do we approach now? You know the definition and everything, right? How do we approach and show this is going to happen? But L to fixed number है ना, कोई it doesn't matter, right? Just some fixed L, right? Epsilon तो लिया है ना हमने, epsilon is equal to 1. नहीं तो फिर वो बाकी वैल्यू अलग हो जाती है. हमको तो see actually if it is true for something I don't care. I want to arrive at a contradiction. For some values I am arriving at a contradiction. Got my point? Okay? I don't have to show that everything it is true, right? I have to arrive at a contradiction. So take some values for which we arrive at a contradiction. I don't have to worry about for all other values, right? What happens? Okay? Got it? Got my point? Because I have to show the arrive at the contradiction. So choose those values for which there is a contradiction. For that, I don't have to worry about. So question is that why we should take some other values, right? So I mean, what I'm saying that we have to arrive at a contradiction. So choose something that is in our hand. So I've taken epsilon is equal to 1, right? If you take epsilon is equal to 2, so maybe I have to choose some other points to show that, you're right? Okay? Some value for which we arrive at a contradiction. Anyway, so now I have to show that this limit is, so A is what here? 3 and L is 15. So what we have in our hand, the definition, so I can say that given epsilon positive, we must find delta positive number such that mod of x square plus 2x minus 15 is less than epsilon. Whenever 0 is less than mod of x minus 3 is less than delta. Okay. I have to show this fact. Given epsilon positive, I have to find delta. So finding delta means I have to decide the neighborhood of 3. Given the neighborhood of L, I mean, which is 15. Okay. Epsilon is given, I have to find delta such that the whole thing makes sense. Now what? Any idea? Anyone in the class? So somehow I have to worry about this expression, okay? To make sense. So what I'm going to sort of expand it and see what factors it is coming. And, can I use some delta? You will see that, observe very carefully how we choose here delta. It's very, very interesting thing, okay? And I'm sure there will be tons of doubts in this example. So watch it carefully. Now, mod of x square plus 2x minus 15 is nothing but mod of x minus 3 times mod of x plus 5. Do you agree? अभी तो काम आसान हो गया इसका मतलब, otherwise it would have been more difficult. Okay? This is fine, right? So this expression I can write it like this. So one factor is mod of x minus 3. So I have to find a bound for this value. right? Because if epsilon we choose, so this whole thing will be less than epsilon, right? This value we know is less than delta, right? I can do that. What about this value? So I have to find this value. So first, very carefully observe, choose delta less than 1. I have to find delta. Remember, epsilon is given to us. I am choosing delta to be less than 1. In that case, what happened? This implies that mod of x minus 3 is less than 1. Because mod of x minus 3 is less than delta. I have taken delta to be less than 1. So mod of x minus 3 is less than 1. Right? So this portion is less than 1. If this is less than 1, what is the value of x? I can find some value of x. So that means I can bound this mod of x plus 5, right? So this implies that x is between 2 and 4. So x plus 5 between 7 and 9, right? Okay. This implies that I can say that mod of x plus 5 is less than 9 if mod of x minus 3 is less than delta is less than 1. Do you agree with this statement? This implies that mod of x plus 5, I have to estimate mod of x plus 5. So mod of x plus 5 is less than 9. If mod of x minus 3, which is less than delta, I know, and I have taken delta to be less than 1, right? So if this condition holds, then mod of x plus 5 is less than 9. Now you know that I have taken delta purposefully less than 1. But I have to find something which depends on epsilon, right, in general. Right? If I substitute, so basically, this whole expression is this mod of x minus 3 is less than delta times mod of x plus 5 is less than 9. So this expression will be delta times 9. What epsilon should I take then? The relationship. So basically, we need to find relationship between epsilon and delta so that it makes sense. Everything makes sense. Okay? So what I am going to do here now. So this implies that mod of x minus 3 times mod of x plus 5 is less than delta into 9. If this condition is given to us. Correct? This whole expression is less than, because mod of x minus 3 is less than delta. Right? And mod of x plus 5 is less than 9. This happens provided mod of x minus 3 less than delta is less than 1. So this whole thing is less than delta into 9. Correct? Any question at this point? I'm going very slow. Please ask or observe any issue here. Correct? Now, remember, I have to show that the whole thing is less than epsilon. If the whole thing is less than epsilon, what delta should I choose? That's the question I am asking. मेरे को मालूम है यहाँ पे तो क्वेश्चन आने ही है, right? That is one, but we have also taken delta to be less than 1. So that means I have to do some more modification. You're right, I mean, right? Because delta is less than 1 also, right? So basically, it is minimum or maximum of 1 and epsilon by 9. What we should take? Less than. So are you getting what is happening here? I have delta, I have now the whole expression should be less than epsilon. So delta should be what? Less than epsilon by 9. But delta is less than 1 also. So what is the appropriate value of delta? Last में क्या हुआ? So the whole expression, what I'm saying that there from the whole x square plus 2x minus 15 is mod of x minus 3 into mod of x plus 5. Mod of x minus 3 less than 1. So we are assuming, because if delta is less than 1, then mod of x minus 3 less than 1, right? Because that is less than delta. That means mod of x plus 5 is less than 9, right? That is okay. So mod of x plus 5 is less than 9. If mod of x minus 3 is less than delta, is less than 1, right? That condition is given to us, right? Now that means the whole product is less than delta into 9. No, I'm saying that we are just estimating. So mod of x minus 3 is what? You can just estimate, right? This whole thing is this and the other thing is that, right? So now I have to choose appropriate delta, right? So if we take, because the whole thing should be less than epsilon. If I take delta to be minimum of, take delta to be minimum of 1 comma epsilon by 9. Then our job is, because delta is less than 1 and the whole thing is less than, right? So in that case, what will happen? Mod of x minus 3 times mod of x plus 5 is less than 9 into delta, which is less than equal to epsilon. As long as mod of x minus 3 is less than delta. This is a general condition, this goal, right? So this means the whole expression. So we have found a delta. Remember, we have found a delta, which is this, for which our equation, this is valid. We have found a delta such that this equation is valid, right? So in these problems, given epsilon, which is the size of the neighborhood, you need to find delta somehow, which is depends on epsilon. Okay? And that is the whole task. Calculate by looking at the inequality of the function, right? Try to estimate the value of delta. That is the only thing, right? So that means this limit exists, right? That means because of the definition, limit x tends to 3, x squared plus 2x is equal to 15. So this was the beautiful thing, right? And this is just starting. You will observe more beauty, right? Slowly, slowly. Okay. So again, when we want to compute limit of a function f of x at a point A on the real line, two things are possible. Either limit exists or does not exist. If you have to show that the limit does not exist, take some specific value of epsilon and arrive at a contradiction somehow, right? Okay. That comes from the observation. And if you want to show that limit exists, that is a bit tricky here. You need to do all this. So you need to be very good in inequalities, right? How do we solve the inequalities and so on, right? Because some function will be there, inequalities will be there. You have to play with the inequalities, and somehow. So you need, in that case, you need to find delta in terms of epsilon. In all the problems, find delta in terms of epsilon. Okay, so that you are done. I know that this is the first time you are encountering beautiful things, so yeah, it might be tricky, right? No, अभी तो जनरल हो गया ना, minimum of 1 and epsilon 9. हमने तो जनरल डेटा कर लिया. तो एक के लिए था ना, फिर उसके बाद में एक्सप्रेशन आया ना तुम्हारा दूसरा 9 into डेल्टा. अब होल थिंग लेस देन एप्सिलॉन है. अब डेल्टा की दो वैल्यूज आ गई, तो व्हिच वन शुड वी चूज? नहीं तो अभी तो अब ये वाला जनरल आ गया ना. So now actually if you again want to feel more, choose some epsilon, say 0.00001, and see what delta you get and see the behavior of the function, how close it is, right? That is the best way. You just plug in the values and see. That is the best way to feel it, right? But in the exams you have to write it like this, epsilon delta business, right? क्या सब ठीक चल रहा है? Yes? Huh? So whole expression is less than 9 into delta. And we know that delta was less than 1 initially, right? For finding one portion of it, right? To estimate one portion. Now here what I'm saying that if whole thing is less than epsilon, this makes sense if delta we choose. So basically you do like this. If delta is minimum of 1 comma 1 and epsilon by 9, you see the whole expression is always less than epsilon, right? If you choose this delta, it will be less than epsilon all the time, right? You can arrive at this, okay? That's another way of looking at it. Now plug in this value of delta and see that the whole thing is always less than epsilon, the whole expression. Okay. Okay, so I think as a practice for the today evening tea, you should do the following. बस एक ही क्वेश्चन करोगे काफी अच्छा है के लिए, राइट? यू विल एंजॉय. लिमिट x टेंड्स टू 1 स्क्वायर रूट ऑफ x प्लस 2 इज इक्वल टू 2. ये तो मालूम ही है ना. सो एप्सिलॉन डेल्टा से करना है, राइट? ओ 3 आएगा ना. लिमिट x टेंड्स टू 1. अरे यार ये बस अब सही है ना. Because we wanted to estimate somehow the expression. Okay. So we observe that if we take delta to be less than 1, we can estimate one portion very, very easily, right? And the other portion, right? And then, but that, because that delta was specific, I need to find this general delta. So we took the whole expression and how it behaves. If the whole expression is less than epsilon, because it was less than 9 into delta, right? Which is less than epsilon. So then we are getting another value of delta, right? Then we have to take delta, which is the minimum of both, which will work in general, no matter what you take, right? So now what I'm saying that in the previous example also, try different epsilon, plug in different epsilon values and see how delta behaves. Okay. In fact, this delta itself that we computed, you can see how it behaves. That's why I say if you use some symbolic computing package such as Mathematica or MATLAB or something, it will be very easy for you to see. Okay. Or I think Wolfram has an online calculator also where you can plug in the values and see how it behaves, right? That way give you some sense. Otherwise, I think once you see the numbers and how they behave, right, you observe the beauty. And the similar thing is that I think what is the value of 0 raised to the power 0? 0 raised to the power 0 कितना होता है? हाँ? Not defined होता है? Limit x tends to 0, x raised to the power x कितना होता है? Limit x tends to 0, x raised to the power x कितना होता है? So that's another tea time problem for you. The limit x tends to 0, x raised to power x. What is the value? U1. Again, even if in the question of x raised to power x, you can do one thing. Plug in different values of x. Okay. Observe the behavior. Okay. You see, and you keep on ranging the value of x, you see the behavior. You will automatically feel what is going on actually. Okay. That's the best way to learn in any of these examples. Plug in different values and see how it behaves. So limit x tends to 0, x raised to power x is 1. But you need to show using epsilon delta, it will be tricky. Delta. Then yes.
If I assume value of both delta and epsilon, then I am having contradiction.